Welcome to Chapter 8.1, The Dynamic Earth. This chapter is one of the very structure of the Earth and its crazy forces that work upon itself, that create mountains of fire and moving continents and all sorts of crazy things like that. What you're looking at here is a volcano in Iceland. I'm not going to attempt to pronounce its name because it's in Icelandic. I'm sure that's not the right language. But it erupted in 2010, covering a lot of northern Europe in a cloud of dust. You might remember it, and basically shut down airports from England and Europe, and really kind of messed with quite a number of things. So it's these kind of forces that we're really discussing today. Let's move right on. One misconception that I really want to stamp on really early is the idea that the crust of the Earth is very thick. It's really not in comparison to the rest of the Earth. It's really thick in comparison to a human. We dig down for kilometres and kilometres, and we don't get anywhere near the surface or the other side of the Earth's crust. But relative to the Earth, it's really thin. And the skin of an apple is really just about as thick as the crust is compared to the core and the molten parts of the center of the Earth. So, really don't have this idea that the crust is really the major component of the Earth. Really, the vast majority of the Earth is molten rock. It's certainly not the vast majority of the Earth is solid. Most of the Earth is as a liquid, I suppose you might say. Look at what makes up the Earth, and we'll work from the outside in. Looking at the atmosphere, really we could say is just a blanket of gases that are attracted via gravity to the Earth so that they don't all float away into space. Really extending the height of Earth, if you include those from the Earth, of about 145 kilometres from its, what we would consider to be the crust. Mostly made up of nitrogen and oxygen, which is necessary for the support of life, obviously, on Earth. Moving down, we have the hydrosphere. The hydrosphere is the water, obviously, hydro for water and sphere for globe. On the surface of the Earth, lakes, rivers, oceans, whatever else. So that's fine, you get all that. Crust, we'll get to the, crust of the issue. Ha ha ha. The Earth's crust, which includes landforms, rocks and soils, mostly solid rock, is rigid and high strength. It's a really rigid structure. I suppose that's the important point. And you can see at places like this, it starts to malform and move in on each other. And other points like this, it creates a volcano. Although a volcano of that size, proportionally to the Earth, would be such a massive, horrible thing that we really shouldn't talk about it too much, lest it happens. But so it varies in thickness, I suppose. As I said, from as little as 5 kilometres to about 70 kilometres, if you consider, it's 5 kilometres, right down the bottom of the ocean. But it's 70 kilometres if you're standing on top of the Himalayas or something like that. So after that, we have what's called the mantle, which is partially molten rock. Temperatures between 500 degrees Celsius to 2,000 degrees Celsius. 29,000 kilometres thick. Compare that. As I was saying, with regards to thickness, 29,000 kilometres thick compared to 5 kilometres thick. It's really the vast majority of what we have on Earth. Yeah. So the top part of the mantle is a source of magma that erupts from volcanoes onto the surface. In an outer core, then now we're starting to head towards the core of the Earth in here. So it's molten iron and nickel. Temperatures mostly between about 4,000 degrees Celsius to 6,000 degrees Celsius and between 23,000 kilometres thick. So it's a big component. just this hard iron and nickel, molten rock in the center of our Earth. And then the inner core, mostly iron. It's interesting at this point, because of the immense amount of pressure. I mean, there's a lot of material all pushing down on the center. It's actually solid. So as you might know, whether something's a solid, liquid, or gas is dependent not only on the temperature, but how much pressure is upon it. You can have something at a very high temperature, but if you squeeze it, if you apply a lot of pressure upon it, it stays as a solid. So this is temperatures of upwards of 7,000 degrees Celsius. You just get an idea of the pressures that this is under. So let's just. So moving on to less kind of dramatic things. What we're looking at here is a map of the Earth, obviously, but it's a map of how various species exist on Earth. And it's all based around this idea that there used to be a supercontinent, Pangaea, that I'm sure you've heard of before. And the idea that all these nations used to fit together, and you can see like the South Africa probably fits in here somewhere, and you can see that this land reptile kind of, probably was together at one point, and you can see this purple bit kind of connects. You see that it fits really well for all that to kind of fit up into here. And when you think about how that can be, it really again points to the fluidness, I suppose, of the crust. The crust is not only not very thick, but it also moves. The continents drift over the periods of millions and millions of years, and used to be a part of one continent, and now they've all separated into the continents that we know today. So that's really all there is to this first chapter, this 8.1, the Earth's crust. So what I would like you to do now is go to chapter 8.1 and put all of the blue words into Quizlet. Okay, put them all into Quizlet. Create a new Quizlet called Dynamic Earth. Put all the blue words in there, and then I'll see you in class. Thanks. Bye.